Hello everyone. In this video, I will go over my solution for the problem named OKEA taken from today's Codeforces round. This problem is an external problem on casework, constructive ideas and some math. So in this problem, we are basically given a grid containing n shelves and there are k goods on each shelf. So in total, there are n shelves into k goods and the ith good has I dollars as its cost, and we are basically going to have to arrange the goods in the shelves in the n by k grid such that the following condition is met. Every number from 1 to n into k should be included in the grid because those represents the cost of each good, and we need to ensure that the mean value for the goods in the range L to R on the ith shelf is an integer. So we need to ensure that for all shelves and for all pairs of indices L comma R, we need to ensure that the mean price of the goods from L to R is an integer. So we basically need to ensure that the average for every contiguous range on every shelf is integral or is an integer, and we need to find and print any valid construction which works, any possible arrangement which works. So let's take an example where n is 1 and k is 1. In this case, we can just place the single good on the shelf. So the answer will be yes, and we'll print 1. If n is 2 and k is 2, then one possible construction is to arrange them 1, 3, 2, 4. In that case, the mean value is 1, 3, 2 and 4 for every range of size 1, and for ranges of size 2 the mean value is 1 plus 3 by 2 which is 2 which is an integer, 2 plus 4 by 2 is 3 which is an integer. So this construction is valid. In the third example, it won't be possible. I'll be explaining in a bit why it's not possible when we move to the solution, but you can basically try all combinations and you'll see that it's not possible to arrange the numbers from 1 to 9 on the 3 shelves such that every contiguous range on a shelf has an integer mean. So that's not possible, so we'll print no. And in the last example, where we have 3 shelves and 1 book on each shelf or 1 number on each shelf, we can basically arrange them in any order as we want, because we know that each range will be of size 1 because the mean price is considered for elements on the same shelf only and within a contiguous range. That's why the range is of size 1 and you can just arrange them in any order because we know that the mean of one element is the element itself. So moving on to the solution, the key idea is to consider several cases for the values of n and k, and let's move to the casework now. So let's first consider a simple case where k is 1, and an example of that case is the last example, the last test case. So in the last test case, we know that when k is 1, we can just print the elements as 1, 2, 3, 4 all the way up till n, depending on what value of n is. So we can write a simple loop which prints these numbers 1 to n, and this is a simple construction which works when k is 1 because every good, every mean value for a contiguous range is an integer which is equal to the number itself, and that's why this construction works. Now let's consider a non-trivial case where k is greater than 1 and n is odd. So the key idea is that if you consider an example where n is odd, so let's say that there are basically let's say that n is equal to 4. So if we take an example of a case when k is greater than 1, the number of elements on each shelf is greater than 1 and n is odd. In that case, the key idea is that if you take two adjacent numbers, one of them being odd and the other one being even, then the average of those two numbers will not be integral because an odd number plus an even number gives us an odd number, and that's why the average of those two will be an odd divided by 2, which will not be an integer. and hence we cannot place two odd numbers, and we cannot place one odd number and one even number together. However, when n is odd, it is actually not possible to ensure that no odd number and no even number are together. And the reason behind that is because if you consider the total number of elements that's given by n into k, and when n is odd, we need to ensure that each shelf contains only even numbers or only odd numbers. So since the total number of odd numbers will be equal to the total number of even numbers, or minus 1 in case like the product, if the product is even, then you need to subtract 1, otherwise you need to keep it same. So the number of odd numbers and the number of even numbers will be approximately equal. However, it's not possible to ensure that the number of elements which are odd and the number of elements which are even are approximately equal, because you need to ensure that each row is either an odd row or an even row containing only odd numbers and even numbers, and you will realize that the difference between the odd numbers and the even numbers will be too large. So for example, in this case, the total number of odd numbers will be like 4 plus 4 plus 4, which is about 12, and the even numbers will be 8. So the difference between 12 and 8 is too much, and you can verify that if you consider different cases, the difference between the number of odd numbers and the even numbers won't be the same as required, because in reality there are 10 odd numbers and 10 even numbers, not 12 and 8. And in other cases also, even when the product is odd, you can verify that, or you will not be able to make sure that there are only odd rows and even rows, and that's why two numbers will have to be next to each other, one odd, one even, and that's why the mean will not be integral. So that's why in this case we'll just print no. And now let's move on to the third and the most general case, which is when k is greater than 1 and n is even. So the key idea for the general case is that the following construction works. If we write the numbers in increasing order along the columns, like in the normal case, we would obviously think of a way in which you'll just write these numbers and you'll check if this construction works. However, as I mentioned, this construction does not work because an odd number plus an even number will give you an odd number. So that will not result in an integral mean. However, if you think about it in a different way, you will realize that this kind of construction seems to work for some examples, and I'll help explain why this kind of construction works, in which we basically write down the numbers in increasing order by basically going through the elements column wise first instead of row wise. So we basically just write the loop with j comma I instead of I comma j. And now let's try and understand why this construction works, of basically going through each column and writing the numbers in increasing order down the column instead of across the row. So the key idea to understanding why this construction works is to consider various numbers. So first, divisibility by 2 is clearly satisfied because each row contains all numbers of the same parity, and basically you can verify that odd numbers and even numbers are in separate rows. So that first condition is met. The second condition is that every 3 contiguous elements should have a sum which is divisible by 3. That also is met. And similarly for the divisibility by 4, and you can also verify that the divisibility by 5 is met. However, like this is just an example, and in this example this construction works. In order to formally understand why this construction actually works for any example or any test case, we need to approach it a bit more mathematically. So if you look at this kind of pattern, you will realize that the cell I comma j contains the number I plus j minus 1 into n. So this is a key idea. Like if you look at the cell I comma j, let's take an example. Let's say I is 1. You're at the first row and you're looking at the second cell. Then it's clear that you are adding n or j minus 1 times. So you're adding n once, and n is 6. So you're adding 6 to I. So 6 plus 1 gives you 7. Similarly, when j is 3, that gives you 13. Next one is 19 and next one is 25. So each time you're adding the number n, and that's essentially why you do j minus 1 into n. Like every adjacent element will be n times n plus the one to its left. That's why it's j minus 1 into n. And you add I because you're increasing the value as you go by the rows. Each element is increasing by 1 as you go down the rows, and it's increasing by n as you go across the column. And that's why I plus j minus 1 into n will be the number of cell I comma j. Now let's consider the general case when you are taking a sum of elements from the range L to R and you're on the ith row. So the key idea is that when you're taking the sum of the range L to R and you're on the ith row, we know that the first element will be I plus L minus 1 into n, because you are at the element I comma L, and we know that I comma L will be I plus L minus 1 into n. So this is the first number. You add that to the second number in the same row, obviously, so I'll write it in a row-wise manner. The second number in the same row is I plus L into n, because this number is I comma L plus 1. Then you add the third number, which is I plus L plus 1 into n, because this element is I comma L plus 2, and you do all the way up till R. So the rth number will be given by I plus R minus 1 into n, because as I mentioned, the general formula is I plus j minus 1 into n for cell I comma j. Now we need to simplify this formula, and we need to verify that this is divisible by the number of elements in the range. So we need to factor it and somehow get the number r minus L plus 1 as a factor. So analyzing this, we realize that the number I appears in each of the r minus L plus 1 elements in the range. That's why we can take that out common. And now what we are left with is we are left with these column wise elements. So we are basically left with L minus 1 into n plus L into n plus L plus 1 into n plus all the way up till R minus 1 into n. And over here also we can take out the n as a common factor. So you can rewrite this as n into L minus 1 plus L plus L plus 1 and all the way up till R minus 1. So it's essentially this sum. And now in order to simplify this number, we can use the simple fact that the sum of elements in the range L to R, like in increasing order, is the sum of an arithmetic progression, or you could just use the fact that the sum of the numbers in the range 1 to R is given by R into R plus 1 by 2, and the sum of the elements in the range 1 to L minus 2 is given by L minus 2 into L minus 1 by 2, and that's why the sum of the numbers in the range L minus 1 to R minus 1. So over here you need to take R minus 1 into account. So like over here the sum of the numbers in the range 1 to R minus 1 is equal to R into R minus 1 by 2, and the sum of the numbers in the range 1 to L minus 2 is L minus 2 into L minus 1 by 2. So that's why the sum of the numbers in the range L minus 1 to R minus 1 will be given by the difference of these two. And you can simplify this, like this is what the difference will be. And now we know that this is the sum of the numbers, this is this quantity. So this quantity can be rewritten as this. And now let's try to simplify the expression further. So the final sum of the elements in the range L to R and the column and the row I is given by this quantity, and in blue I just copied it from the top portion. So that's the blue quantity, and the red quantity is the original values. So now we need to find a way to simplify this expression, and we need to ensure that the whole number is divisible by R minus L plus 1. So we can simplify this expression by first expanding it. So if you expand this quantity in blue, you will get this quantity in red, and this is what it will simplify to. You can multiply this out and check that this is equal to this. So obviously you need to divide by 2. So this is the quantity, And you will realize that r minus l plus 1 is a factor. That's how I actually factored it, keeping that in mind. So basically what we are realizing is that the sum of elements is actually I into r minus l plus 1 plus r minus l plus 1 into r plus l minus 2 divided by 2 and into n, because n is initially there. This is the whole sum of elements, and we take out the quantity r minus l plus 1 out common, because we are trying to prove that r minus l plus 1 divides the this whole expression. And if we just take the factors out, you will realize that this is what we are left with. And this quantity in blue over here is actually an integer. So the reason why this is an integer is because we know that n is even. So this is where n is even comes into picture. The reason why n is even was required is because we know that this quantity r plus l minus 2 need not be an integer. However, n is an even. N by 2 is an integer because n is even, and that's why when we add an integer to I, and when we multiply it by r minus l plus 1, we get another integer which is divisible by which basically is a multiple of r minus l plus 1. And now you can see why n is even comes into play. And this essentially proves the fact that the sum of elements in the range L to R in the ith row is divisible by r minus l plus 1, and hence the simple construction of writing the numbers in increasing order down the columns works. So I'll show you the code which just prints the grid as you saw in the picture. So in the code, for each test case, I taken the value of n and k. If k is 1, this falls under case 1. This means we will print yes, because we know that simply printing number I on the ith line is enough. When n is even, I mean when n is odd, we know that this quantity will not be integral for some value of L and R, and that's why we will print no. However, if n is even, this is the final case. In that case, we create the vector of answers, and what we are essentially doing in this loop is setting answer of I comma j to be the current value, and we increase the current value by 1, where we are iterating through the columns first. So iterate through the columns first, and this is basically this is exactly the same as the diagram where we increase the number as we go down the columns. So that's the key thing which we are doing over here. We are going down the columns and we are increasing the number column wise, and then we are going across the rows. So in this way, if you run the j loop first and then the I loop after that, you can just set the answer to be the current number, and in the end obviously you will print it in the correct order, which is the I loop and then the j loop. So in this way we basically ensure that the answer grid contains one possible value of a valid construction, and you can verify this code gets accepted. So I hope you like this problem and my solution. If you had any doubts, do leave them in the comments down below, and if you like this video, don't forget to give it a thumbs up. Thank you.